Many physical properties that soil has. One of the most important one is soil texture. Soil texture, the other physical properties include texture, moisture, but all these are in turn influenced by the texture of soil. So what is the texture of soil? Now, if we go to texture of soil, we see that soil texture is actually the relative proportion of sand, silt and clay in a soil. The three separate kinds of soil separates, that is coarse sand or fine sand, that is sand, which is the coarse soil separate. Then there is silt, which has a diameter of 0.02 to 0.002 millimeter, that is in between sand and clay, and the finest soil separates are clay separates, which have a diameter of less than 0.002 millimeter. So sand is the coarsest and clay is the finest, and the relative proportion of these three in a soil determine the texture of the soil in general. So based on that, there have been 12 textural classes that have been divided. These 12 textural classes are named thus. They are ranging from sandy soil, clay soil, loamy soil, sandy loamy, sandy clay. So there are a number of combinations which have been made, and there are 12 main soil textural or principal soil textural classes. These soil textural classes are represented through a diagram which is known as a textural diagram or ternary diagram, or textural ternary diagram. Let us go to a textural ternary diagram, but before that let us just have a view of uh, a data set. For example, this is of a district in Nadia in West Bengal, and the village is Politbegia. In this village, there were 5 soil samples taken at different depths of 0 to 3 inches, 3 to 13 inches, 13 to 20 inches, 20 to 38 inches, 38 to 48 inches. In each of these depths, the 5 soil samples considered, the percentage of sand, silt, and clay was determined by various scientific method and field-based methods. Now we have to remember that these 5 textural classes, didn't amount to a total of 100%. Sand, silt and clay in each of the samples were not 100%. So they were arithmetically adjusted into 100%. Arithmetically adjustment into 100% and increased slightly their percentage. The percentage share where it was less than 100 was adjusted and proportionately distributed among the three sand, silt and clay classes. Now assuming we have the proportion of sand, silt and clay in a sample, so how do we represent it in a ternary diagram? So let's first go and see a ternary diagram. This is the ternary diagram. It has 3 axes: the sand on the x-axis or the horizontal axis. The clockwise going, the next axis represents clay percentage, and the third axis represents the silt percentage. Here the sand percentage increases from 0 to 100% as we move clockwise. Same for clay, 0 to 100%, and same for silt, 0 to 100%. The 12 textural classes are sand, loamy sand, sandy loam, sandy clay loam, sandy clay, loam, which is ideal balance of sand, silt and clay, silty loam, silt, silty clay loam, silty clay, and clay. These depend on the share of sand, silt, and clay percentage which have been specified by the international organizations. Now, these 12 principal textural classes are known. Now, this is an equilateral triangle, and if we say 1 centimeter is 10 percentage, then this 10 percentage we draw divide the, this into 100%, we divide this axis into 100%, and we divide the third axis as well into 100%. So now we join the 10% to the 90% diagonally. We have to measure each percentage as per the direction of these lines. So if we measure the sand percentage, the axis previous to sand, parallel to those we will measure the sand percentage. So this is the sand axis, and the axis previous to sand is this axis, which is going vertically like this or diagonally like this. And so sand percentage, if we have say 25%, this is the line where we will measure 25% in this direction. Now clay percentage, again we will be measuring it. This is the previous axis horizontal. So if clay is 25%, we will be measuring along this line, these lines horizontal. Now silt percentage we will be measuring as per the previous axis direction. So like this. Wherever these three merge, that is the textural class of that soil sample. So how do we determine this? Let's take one example. We have 51% sand in sample N49, 30 percentage of silt approximately, and approximately 20 percentage of clay. So 51, 30 and 20. So if we say 51, 51 is, remember, sand. So 51 sand, this is 50, this is 60. So if we go diagonally like this, we draw a line, dash dash line around this. Uh, let's insert a shape and then we'll be able to do it better. Let's insert a shape. So if we say 51%, I'm sorry. So this is approximately right along this. So 51% will be a line going like this, right? Now we had about 30 percentage of silt. Now silt, remember, is this axis. So if we take silt of 30%, we measure along this line. So this is the line, and around 19% to 20% was clay. So 19 to 20%, slightly less than 19, greater than 20, this. So let me make these lines bolder, then we'll be able to visualize them better. Let's increase the thickness. It's actually slightly thicker than we wanted. Similarly for this line, let's increase the thickness. Similarly for the third line we plotted, let's increase the thickness. Now this intersection of these three lines indicates very clearly that this soil sample is predominantly lies in which textural class? The loam textural class. So it's a loamy soil, an ideal distribution of sand, silt and clay. Now let us see the next. If we see this deepest, this was at the surface, the deepest sample has about 10% or 11 percentage of sand, 27 percentage of silt and about 62 percentage of clay. So 11 percentage of sand. Let's go to 11 percentage of sand. 11 percentage of sand, that comes to around line like this approximately. Let's change its color so that we can differentiate from the other sample. Then we had a silt of 27%. So 27 percentage of silt, I believe we need to increase the line. So 27 percentage of silt means about, this is 25, 20, this is 25, so 27% will be approximately this. Silt will be measured like this because it's an axis which is parallel to the clay axis, the previous axis. And we have a 62 percentage of clay. So if we have a 62 percentage of clay, so this is 60, this is 65, so 62 will be somewhere here, this, around this. So now we can see very clearly that our deepest soil is actually clay soil. So this seems to be a mature soil as the amount of clay seems to increase with depth. So the deepest soil lies in which textural class clay, and the top soil lies in the which textural class loamy textural class. This is how we can determine the textural class if we know the sand, silt and clay percentage determined in the field through some scientific and field-based uh, experiments and methods. So, but what is the importance of knowing these? Now, since we know the topsoil is loamy or loam, so this is ideal situation for cultivation of crops. So, loamy soils are best suited for cultivation of crops. So, textural soil, how coarse or how sandy or how clay it is, also help determine how much moisture retention it can have, what will be the permeability, porosity. Like more sand means more coarse means more porosity, permeability, and the water retention will not be there. It will not be good for cultivation of crops. But if it's a loamy soil, it's ideal balance. So there will be ideal permeability, porosity, and a definite soil structure, and very good for crop cultivation. And a clay type of soil, like if this would have been in the top surface or top soil, then this would have definitely not be suitable for agricultural purposes, as clay gets very cloddy when wetted and is not suitable for agriculture at all. So, soil texture is the relative percentage of sand, silt, and clay, and it helps determine uh, what kind of land use practice is conducive for that region or agriculture is possible for that region. And this can be determined through this ternary diagram if we have the sand, silt, clay percentage. So texture is very important because it also determines other properties like structure and drainage and water, soil water or moisture, and thus also indirectly or indirectly impacts the suitability for agriculture. Thank you. That was all regarding soil texture.